Pricing electrical inspection and certification services involves several considerations. Firstly, time and effort are crucial. Determine the time required for the inspection and report preparation, including travel time to the location. Secondly, expertise and reputation play a role. Consider your experience and qualifications as a licensed electrician and how that affects the value you bring to the inspection. Thirdly, market value is important. Research industry rates and comparable services in your area to understand what others are charging. Fourthly, consider additional services. Assess if additional services, such as written certification or repair recommendations, are required, and factor those into your pricing. A common pricing structure involves either an hourly rate or a flat fee. With an hourly rate, you charge a set rate based on your time spent inspecting and reporting. With a flat fee, you offer a flat fee that covers the entire inspection and certification process. A suggested pricing range for an hourly rate is $50 to $100 per hour, but this may vary based on your experience and location. A suggested pricing range for a flat fee is $250 to $500 per inspection. To provide the best service and avoid disputes, keep a few additional tips in mind. Firstly, estimate the time. Provide the person with an estimate of the time it will take to complete the inspection, so they know what to expect. Secondly, explain the process. Clearly outline the scope of the inspection and the documentation that will be provided, so they understand what they are paying for. Thirdly, consider requesting payment upfront for the inspection to avoid disputes later on. Fourthly, offer a guarantee that the inspection results are accurate and reliable to build trust and confidence. Always maintain a professional demeanor throughout the process and provide clear and concise communication to ensure a positive experience for everyone involved. When performing an electrical inspection, you're essentially evaluating the safety and code compliance of the electrical system in a building. This involves visually inspecting wiring, devices, and equipment for defects, hazards, and code violations. Here is a more detailed breakdown of what to look for. Look for proper wiring methods, including the correct type and size of conductors for the application. Ensure that wiring is properly supported and protected from physical damage. Check for any signs of damage to the insulation, such as cracking, fraying, or melting. Inspect all electrical connections for tightness and corrosion. Look for proper grounding and bonding of all electrical equipment and systems. Verify that the grounding electrode system is intact and properly connected. Check for any signs of improper grounding, such as loose connections or corroded grounding conductors. Inspect all overcurrent protection devices, such as circuit breakers and fuses, to ensure they are properly sized and functioning correctly. Verify that circuit breakers are not overloaded and that they trip when tested. Look for any signs of overheating or damage to overcurrent protection devices. Inspect all receptacles and switches for proper installation and operation. Verify that receptacles are properly grounded and that they provide a secure connection. Check for any signs of damage or overheating to receptacles and switches. Inspect all lighting fixtures and lamps for proper installation and operation. Verify that lighting fixtures are properly supported and that they are not overloaded. Check for any signs of damage or overheating to lighting fixtures and lamps. Inspect all electrical panels for proper labeling and organization. Verify that all circuits are clearly labeled and that the panel is not overcrowded. Check for any signs of damage or overheating to electrical panels. Look for any exposed wiring or electrical hazards that could pose a risk of shock or fire. Ensure that all electrical boxes are properly covered and that there are no openings that could allow access to live parts. Check for any signs of water damage or corrosion to electrical equipment. When inspecting electrical systems, it is essential to adhere to the National Electrical Code, or NEC, which provides the standards for safe electrical installations. Some of the key areas to focus on, based on the NEC, include the following. Article 110 addresses the general requirements for electrical installations, including workmanship, equipment listing, and marking. Article 200 covers the requirements for grounded conductors, including identification, sizing, and connection. Article 210 provides the requirements for branch circuits, including the number of outlets allowed on a circuit, the ampacity of conductors, and the type of overcurrent protection required. Article 220 covers the requirements for calculating branch circuit, feeder, and service loads. Article 230 addresses the requirements for services, including the size and type of service conductors, the location of the service disconnect, and the grounding requirements for the service. Article 250 provides the requirements for grounding and bonding, including the grounding electrode system, equipment grounding conductors, and bonding of metal parts. Article 300 covers the general requirements for wiring methods, including the type of wiring allowed, the support and protection of wiring, and the installation of wiring in damp or wet locations. Article 310 provides the requirements for conductors for general wiring, including the ampacity of conductors, the insulation requirements for conductors, and the dirting of conductors in high-temperature environments. Article 400 covers the requirements for flexible cords and cables, including the type of cords allowed, the ampacity of cords, and the protection of cords from physical damage. Article 404 addresses the requirements for switches, including the type of switches allowed, the installation of switches, and the grounding of switches. Article 406 provides the requirements for receptacles, including the type of receptacles allowed, the installation of receptacles, and the grounding of receptacles. Article 408 covers the requirements for panel boards, including the type of panel boards allowed, the installation of panel boards, and the overcurrent protection of panel boards. Article 410 addresses the requirements for luminaires, lamp holders, and lamps, including the type of luminaires allowed, the installation of luminaires, and the wiring of luminaires. Article 430 provides the requirements for motors and motor circuits, including the type of motors allowed, the overcurrent protection of motors, and the control of motors. Article 440 covers the requirements for air conditioning and refrigerating equipment, including the type of equipment allowed, the overcurrent protection of equipment, and the control of equipment. Article 445 addresses the requirements for generators, including the type of generators allowed, the overcurrent protection of generators, and the installation of generators. Article 450 provides the requirements for transformers, including the type of transformers allowed, the overcurrent protection of transformers, and the installation of transformers. Article 500 through 516 address the requirements for hazardous locations, including the type of equipment allowed in hazardous locations, the wiring methods allowed in hazardous locations, and the grounding requirements for hazardous locations. Remember, this is not an exhaustive list, and it is essential to consult the NEC directly for specific requirements and to stay up to date on the latest code changes. The inspection report should be thorough and detailed, clearly outlining any issues found and providing recommendations for corrective action. Be sure to document all findings with photographs or videos to support your report. When providing repair recommendations, be specific about the work that needs to be done and the materials that will be required. Offer options for repair whenever possible, and be transparent about the costs involved. When providing a guarantee for your inspection results, be clear about the scope of the guarantee and the limitations that apply. Be sure to honor your guarantee if any issues arise after the inspection. Maintaining a professional demeanor throughout the process is essential for building trust and confidence with your client. Be respectful, courteous, and responsive to their questions and concerns. Communicate clearly and concisely, avoiding technical jargon that they may not understand. Provide regular updates on your progress and be transparent about any challenges or delays. By following these guidelines, you can provide a valuable service to your clients and establish yourself as a trusted and reliable electrician in your community. In residential electrical systems, some common issues to watch out for include the following. Knob and tube wiring, which is an outdated wiring method that is not grounded and can be a fire hazard. Aluminum wiring, which was used in some homes in the 1960s and 1970s and can become loose and overheat, posing a fire hazard. Overloaded circuits, which occur when too many electrical devices are plugged into a single circuit, causing the circuit breaker to trip. Grounding issues, which can cause electrical shock and damage to electronic equipment. Improperly installed or damaged receptacles and switches, which can pose a safety hazard. In commercial electrical systems, some common issues to watch out for include the following. Three-phase power imbalances, which can cause motors to overheat and fail. Improperly sized or installed overcurrent protection devices, which can lead to electrical fires. Lack of surge protection, which can damage sensitive electronic equipment. Code violations, which can result in fines and penalties. In industrial electrical systems, some common issues to watch out for include the following. High voltage hazards, which can cause severe electrical shock or death. Arc flash hazards, which can cause severe burns and injuries. Motor control issues, which can lead to equipment downtime and production losses. Hazardous location issues, which can cause explosions or fires. When dealing with any electrical system, it is important to follow all safety precautions and to use the appropriate personal protective equipment, including gloves, eye protection, and insulated tools. If you are not qualified to perform electrical work, it is important to hire a licensed electrician to do the job. Remember, electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. The following are steps in an electrical inspection. Firstly, preparation, which involves gathering information about the property, including its age, size, and type of construction. Secondly, visual inspection, which involves walking through the property and looking for any obvious electrical hazards or code violations. Thirdly, testing, which involves using electrical testing equipment to verify the safety and functionality of the electrical system. Fourthly, documentation, which involves creating a detailed report of the inspection findings, including any recommendations for corrective action. Finally, certification, which involves providing a written certification that the electrical system is safe and in compliance with applicable codes and standards. Different types of electrical inspections include pre-purchase inspections, which are performed before a property is sold to identify any potential electrical problems. Rental inspections, which are performed to ensure that rental properties are safe and in compliance with applicable codes and standards. Insurance inspections, which are performed to assess the risk of electrical hazards for insurance purposes. Code compliance inspections, which are performed to verify that electrical installations meet the requirements of the National Electrical Code and other applicable codes and standards. Some other examples of electrical issues would be loose connections, which can cause arcing and overheating, posing a fire hazard. Damaged wiring, which can expose live conductors and create a shock hazard. Overloaded circuits, which can cause circuit breakers to trip and can lead to overheating and fires. Grounding problems, which can prevent electrical equipment from being properly grounded, increasing the risk of shock. Water damage, which can damage electrical components and create a shock hazard. Burn damage, which can damage wiring and insulation, creating a fire hazard. The electrical panel is the heart of the electrical system, distributing power to all the circuits in the building. Key components include the main breaker, which disconnects all power to the panel. Circuit breakers, which protect individual circuits from overloads. Bus bars, which distribute power from the main breaker to the circuit breakers. Grounding bar, which provides a connection point for grounding conductors. Neutral bar, which provides a connection point for neutral conductors. The NEC specifies the requirements for electrical panels, including the following. A panel must be properly sized for the load it will serve. The panel must be located in an accessible location. The panel must be properly grounded and bonded. The panel must be properly labeled. The panel must be protected from physical damage. In addition to the NEC, there may be local codes and regulations that apply to electrical inspections and certifications. It is important to be familiar with these codes and regulations before performing an inspection. The International Association of Electrical Inspectors, or IE, is a professional organization that provides education and resources for electrical inspectors. The National Fire Protection Association, or NFPA, is a non-profit organization that develops codes and standards for fire prevention and electrical safety, including the National Electrical Code. Local building departments are responsible for enforcing building codes and regulations, including electrical codes. Electrical inspections are an important part of ensuring the safety of buildings and their occupants. By following the guidelines outlined in this information, you can provide a valuable service to your clients and help to prevent electrical hazards.